that have already taken part in the first part of the entire syllabus. You have taken this first part out of the 6 parts. Number 1 is number basis. Number 2 is fractions, decimals, and approximations. Number 3 is indices. Number 4, logarithm. Number 5, sequence. Number 6, sets. Number 7, sorts. Number 8, rates, proportion, and ratio. Number 9, variation. Number 10, percentages. All of these topics I just mentioned, 10 of them are under numbers and numeration. Today we will be looking at number bases. The key bases are binary and denary number. The key bases or the most common that you will encounter are binary and denary. Binary is a base in 2, while denary refers to numbers in base 10. All numbers except otherwise stated are denary numbers. All numbers except otherwise specified are denary numbers. That's why when we add, okay, for instance, we add in numbers, this is 100, tens, and units. Those days in the primary school, that's why when you add the numbers here, unknown to us or known to us at our own levels, we never knew that these numbers are already expressed in base 10. And that's why when you borrow a number, you borrow exactly 10. That's why when you are adding, you cannot write a number that is above 9. You cannot write 10 exactly. Let me give you an example in this. 5 plus 6 is 11. You cannot write 11 here. You will subtract it, you subtract 10 from it, and then you write your remainder. That's why you write 1, carry 1. Again, 2 plus 9 gives you 11. Again, you cannot write 11 because this number is in base 10. You add the number you're carrying to it, it becomes 12. You take 10 away from 12, you write the remainder, which is 2. Again, you are carrying that 1 digit. So 1 plus 3, you have 4, and then plus the one you are carrying, you have 5. This is an addition in base 10. All numbers except otherwise stated are base 10 numbers, and they are otherwise known as denary numbers. Again, there are other numbers. Let me say the second most common or the second commonest basis that we deal with on the number basis are binary numbers. These are numbers that are expressed in base 2, and you will never see a binary number where 2 is part of the digits. These are some of the things we'll discuss as we progress under this topic. Binary numbers are base 2 numbers. The highest digit is always 1. When you see a binary number, how to identify is the highest digit or the highest number is 1, and so on for the various bases. When a number is expressed to the base of 3, the highest number will be 2. When a number is expressed to the base of 4, the highest number will be 3. Consequently, until you get to 10, the highest number will be 9. A number in base 10, the highest number will be 8, and so on and so forth. So let's go quickly to conversion of bases. One of the key things, apart from addition, subtraction, and multiplication, that you're going to be carrying out as operations under number basis, one of the most important things you will do under number basis is we do conversion from base 2 to base 10 and other bases. We also convert base 10 to base 2. We convert other bases to other bases. We convert from one base to another other than 2 and 10. But let's start with conversion of base 10 to base 2. The first one we're going to be doing now on the number basis, we are looking at base conversion. base conversion, and we are looking at base 10 to base 2. If, for instance, I ask you to convert a number in base 10, I say convert 45. Usually we do not put 10 there, to base 2. The first thing we'll do is to create a column of this type. You put 45 on this side, and you put the number you want to use to convert to this side. 2 in this case is what we are using. Then you use 2 to divide 45 consecutively until you get to the last number where 2 cannot go, where is not divisible by 2. So if you take 2 in 4, you have 2. 2 in 5, you have 2 again, remainder 1. 2 in 20, you have 11, remainder 1. 2 in 11, you have 5, remainder 1. 2 in 5, you have 2, remainder 1. And then 2 in 2, you have 1, remainder 0. If you look at it, you will discover that we have gotten to 1. And since 2 cannot go in 1, you say 0, remainder 1. 2 cannot go in 1, so you say 2 in 1, 0, remainder 1. Now, the one thing I want you to pay close attention to is how I will write out my answer. Sorry, this is 0. There is no remainder when you divide 22 by 2. It's 11, remainder 0. One thing that will help you as you convert base 10 to base 2 is you must understand that you always read your answer from bottom upwards. Answer is from bottom upwards. Answer is read from bottom upwards. Answer is read from bottom upwards, and that's why you see the arrow is going upwards. So the number in base 2 that is equivalent to 45 base 10 is 1 0 1 1 1 0 1 1 0 1 base 2. So 45 base 10 is equivalent to 1 0 1 1 0 1 1 0 1 1 0 1. That is conversion of base 10 to base 2. Any number whatsoever, this is the process. Please don't make the mistake. Make sure you consider it well. Make sure you look at it that it has a remainder, and make sure you discover that it doesn't have a remainder. One of the things, like I said at the beginning of this lecture, is that you will discover that when you have a number in base 2, the highest digit will be 1. The highest digit will be 1. Again, let us try to consider the conversion of base 2 to base 10. Now, let's see how we do this. I'd like you to pay close attention to these formats that I'm going to do here. We just converted base 10 to base 2. Let's use exactly what we got to convert back to base 10. Convert this back to base 10. The difference between this one is that it's a series of multiplication and is a series of ascribing powers to the number you are converting. This is 2. This is 2. So we have 1 0 1 1 0 1 base 2 to base 10. To do this, each digit, we have 6 digits, 1 2 3 4 5 6. Each digit of the binary number is multiplied by 2, which is the base. Each digit of the binary number is multiplied by 2 and added to one another. and increasing powers are ascribed to the 2's from 0. Increasing powers or ascending powers are ascribed to the 2's, not to the digits that you were given, but to the 2's. Increasing powers are ascribed to the 2's from 0, starting from the first 2 from the right. Again, you will ascribe ascending powers starting from the last 2. You put 0 on the last 2 and you increase it accordingly until you get to the last 2 on your left. I'm going to demonstrate that on the board. What I said is you will multiply each digit here, 1 times 2 plus the next digit is 0 times 2. The next digit is 1 times 2. The next digit is 1 times 2. The next digit is 0 times 2. And then the last digit again is 1 times 2. You see that I put addition sign for all of the 6 digits, and I multiply each digit by 2 because we are converting a binary number, a number in base 2, we are converting it to base 10. Then I said in the later part of that sentence, or in the activity that you need to do, what you need to employ to get this, we now start ascribing powers or indices starting from the last 2, and you always start with 0. The next 2 you will put 1. The next 2 you will put 2. The next 2 you will put 3. The next 2 you will put 4. The next 2 you will put 5. Don't start ascribing it from here. It is always from right to left, never from left to right. From the last 2 you put 0 and then you increase it accordingly until you get to the last digit. If you multiply all of these out, you will get back 45. If you do not get 45, that means your calculation is wrong. Let's do it together. 2 raised to power 5 is 32. If you multiply, 2 raised to power 5 is 1, 2 times 5. 2 raised to power 5 is 2 in 5 places, meaning you should multiply 2 5 times. 2 times 2 until you get to the last 2. What you get is 32. 0 times 16 plus 1 times 8 plus 1 times 4 plus 0 times 2 plus 1 times any number raised to power 0 is 1. So you come back here again, you have 1 times 32 is 32. 0 times 16 is 0. Any number multiplied by 0 gives you 0. 1 times 8 is 8. 1 times 4 is 4. 0 times 2 again is 0. 1 times 1 is 1. If you take time to add all of this together, you will discover that this is 32. 8 plus 4 is 12. Plus 1 is 13. And then you now have 45 base 10. 45 base 10. That is conversion of binary number to base 10 numbers. Conversion of binary to base 10. Conversion of binary to base 10. Alright? Now let's look at conversion from base to base. We've done a conversion from base 10 to base 2. We've done conversion of base 2 to base 10. Let us look at what you need to do when you are converting from base to base. The one that we're going to consider, let's look at this example. This one is conversion from base to base, and it could be any base. From base to base. All right, we have example 3. It says convert 450 base 3 to base 6. Let me explain what we need to do in this situation. To do this, the base 3 or any other base whatsoever is first converted to base 10. You will first of all convert the given base, which whatsoever, you convert it first to base 10. after that number has been converted to base 10, convert the base 10 number to base 6 or any other specified base. Let me repeat that. When you are given a question other than base 2 and base 10, let's say for instance you are asked to convert base 4 to base 9, or you are asked to convert base 5 to base 8, the first step or the first thing you need to do is to convert that given base to base 10, and then you consequently convert base 10 back to the given or the specified base. So in this case, what we're going to do is to convert 450 base 3 to base 10. And just like we did for base 2, you do the same thing here to base 3 to convert it to base 10. And therefore follows, you take 4, the first digit, multiplied by the base, which is 3. You put addition sign. You take the second digit, which is 5, multiplied by the base, again, which is 3. Now you put addition sign again, and then 0 times 3. Then like I said, for the conversion of base 2 to base 10, I said you start ascribing powers right from the last base, which is 3 in this case, and then you start with 0. The next one will be 1, the next one will be 2, and then you multiply it out, then you get a number in base 10. In this case, we have 3 raised to power 2 is 9, plus 5 times 3 plus 0 times 1. Any number raised to power 0 is 1. 4 times 9 is 36. 5 times 3 is 15. 0 times 1 is 0. So eventually, what you have is you have 51 base 10. 51 base 10. It is this 51 base 10 that you are now going to convert to the specified base, which is base 6 in this question. So let's try to convert base 10, 51 base 10 to base 6. You must have your knowledge of multiplication table handy. These are the days when students do no longer put anything in their memory. What they do is to rely permanently on calculator. But there are days where you would need your own memory card, which is within your score. That's why I encourage you as a student of mathematics, at whatever level you are, you must be able to reproduce the answers to simple multiplication table. Like in this case now, your knowledge of multiplication table will come handy. How many times will 6 go in 51? If you know your multiplication table 6, you know that 6 times 8 is 48. And so then you write 8 times, and then you subtract 48 from 51, which will give you 3. Again, we say 6 in 8. Of course, this is simple. You have 1 9, and then you have remainder 2. Then 6 again in the last number, which of course is less than 6. Then you put 0, remainder 1. And again, like I said, your answer is read from bottom upwards, from bottom, and then you see the arrow here, which will help you to know that you must read it that way. 1 2 3 base 6. 1 2 3 base 6. 1 2 3 base 6. This will help you a great deal. Now, what about addition, subtraction, and multiplication in bases? If you are a good student of maths, I'm sure you would have noticed that I did not mention division. I looked at the syllabus before I embarked on this project, and I discovered that in the syllabus, the operation division was left out. So we will restrict ourselves only to addition, to subtraction, and to multiplication. The operation division has been left out in the syllabus. So our emphasis will be on the other 3 operations, which are additions, subtraction, and multiplication. Any of the bases will be selected at random. Please note that what obtains in the selected base is what obtains in the rest. In the rest. So our choice in this case is base 4. Our choice in this case is base 6. We'll be doing all the things we're going to do in base 6. And I want you to look at this. Look at this question. Given that A equals to 3, 4, 5 base 6 and B equals to 43 base 6, determine 1. A plus B, 2. A minus B, 3. A times B. Determine A plus B, which is addition, A minus B, which is subtraction, and A multiplied by B, which is multiplication. Now the first one we do is the addition, A plus B. Mind you, I said we are dealing in base 6. So we have 3, 4, 5. We have plus 43. Mind you, this is a working or operation in base 6. And it's good for me to first of all explain something to us so that when I start working, you will understand what I am doing. If I add 5 plus 3, ordinarily, in what you are used to in regular normal regular binary operations, all I will just do is to write 8 here. But because I'm dealing in base 6, I cannot do it. And that's why I want you to pay a very close attention. When you are adding and you are working in a particular base, the base you are working at or you're working in per time determines the highest digit. Let me repeat that. When we are working in base 10, you cannot work and get 10. It's not possible. It's not possible. When you are working in base 9, you must not get 9 as part of your answer. When you are working in base 6, you must never write any digit or any letter here that is above the specified base. You cannot write anything that is beyond 6. You cannot even write 6 itself. You can only write digits from 5 downwards because you are operating in base 6. So look at this first one we did. 5 plus 3 here gave us 8. 5 plus 3 gave us 8. We cannot put 8 here because of the base that we are working with. So how do we do it? You will divide your answer by the base, which in this case is 6. And then 8 will now be, it will be the same thing as 1 times 6 plus 2. 1 times 6 plus 2. And that will help us to know what we're going to write. You will always write the remainder. If what you have gotten is greater than 6, then divide your answer by 6, which is what I've done here. 8 divided by 6 will give you 1 remainder 2. 8 divided by 6 will give you 1 remainder 2. 6 will go in 8 one time and it will remain 2. After you've done that, you will write the remainder always. Only the remainder. You will write the remainder and you will carry this 1. The answer of the division, which is 1, is what you will add to the next number or to the next action you're carrying out. Like in this case, we got 2 as a remainder. You put the 2 here and then you add this 1 to the next numbers you want to add together. In this case, we have 4 plus 4 plus this 1 that is left. That gives us 9. When you get 9, again, it's impossible to write 9 here. And the reason is you are working in base 6. Just like you did for 8, you will do again for 9. 9 divided by 6. When you divide 9 by 6, you will get 1 remainder 3. Again, just like you did for this 2, you do for this 2. You write 3 here and you carry this 1. Then you write that 1, you add it to what is left in this place. 1 plus 3 now becomes 4. So this is addition in base 6. Your answer you are getting is 432 base 6. 432 base 6. Very, very important. Let me repeat myself. The question says you should add 2 numbers that are in base 6. It is wrong to do what you do in base 10. In base 10, if you add 5 plus 3, you will get 8. And all you need to do is to put it here. But in base 6, you cannot do that because the law says if a number is in base 6, you cannot express that same base in the digits. That is why the highest number for any number in base 6 will be 5. 5, never 6. That's why when we added 5 plus 3, we got 8. We have to divide the answer or the result by 6. When we divided 8 by 6, we got 1. And we add 2 as our remainder. You will come back to where you are working to your base station and you will write 2. And the one that you are getting as your answer, you will add that one to the next operation, which is 4 plus 4. What we did there was to add 4 plus 4 plus 1. This one here was the one we wrote here. We got 9. Again, you cannot go and write this 9 here under this column. No, it's not correct because again, you are working in base 6. Just like you did for 8, you now say 9 divided by 6. And then you add 1 remainder 3. Again, you come and write the 3, which is the remainder, and you add this one to the next column. And in this column, we have only 3 left here. So we have 3 plus 1, which gives us 4. So the final answer is 432 base 6. Let's go to the second question, which is A minus B. A minus B. I believe you understood the first working. The second one is almost the same thing. The process is the same. Just make sure that 6 does not appear in your answer. We have 3, 4, 5 minus 4, 3. 3, take away 3 from 5, you will add 2. The reason why we are writing 2 directly is because 2 is not greater than 6. Take 4 away from 4, we add 0. And then the last one will be 3. So your answer for that one is cheap, is simple, is 302 base 6. The subtraction is a little bit cheap. But let me give you another example under subtraction so you will understand what you need to do in case you are faced with this kind of question. Look at this. 3, 2, 5 minus 54. If you take 4 away from 5, you have 1. If you take 5 away from 2, it's impossible. You cannot subtract 5 from 2. So you go to Mr. 3 and borrow 1 from him. If you borrow 1 from 3, the one you borrow is equal to the base you are working in. You are working in base 6. And so the one you borrow here is equal to 6, not equal to 10. The reason why when you borrow number previously in the former operations you used to is equal to 10 is because you are working in base 10. But in this case you are working in base 6. So when you borrow 1 from 3 is equal to 6. You add it to 2, it becomes 8. If you subtract 5 from 8, what you get is 3. What you get is 3. So the answer here will be 3. and you have already borrowed 1 from 3, you have left 2. Let me quickly repeat that. If this is the second question you were given, 3 to 5 minus 5, 4. Take 4 away from 5, you will get 1. If you want to take 5 away from 2, it's impossible. You will borrow 1 from 3, and you will add it to 2. And the one that you have borrowed is the equivalent of the base, which in this case is 6. 6 plus 2 becomes 8. And then 8, you now take 5 away from 8, in which case is 3, and then you write 3 as your answer. And then the one that is left here is 2. So that is subtraction in a base. Subtraction in a base. Alright, the top one or the third operation is multiplication. Multiplication, just like we have for A multiplied by B. Now look at this. A is 3, 45. B is 43. Again, I have already specified and I have told us that we are dealing with base 6. That you must put at the back of your mind each time you are dealing in number bases. The base with which you're working is very crucial. Once you lose sight of it and it becomes inconsequential to you, you start losing marks from the very point you have thrown away the consciousness of the base with which you're working. In this case, we are looking at the first digit here, which is 3. 3 multiplied by 5, you get 15. Again, like I said, you cannot write 15 because you are working in the 6. So you divide 15 by 6. If you divide it properly, you will discover that 6 will go in 15 2 times and you remain 3. It is that remainder you write. The remainder is what you write, this 3. That's what you write, and you carry 2. Again, you say 3 times 4, you get 12. 12 plus these 2, 12. 4 times 3 is 12 plus these 2 will give you 14. Again, you divide it by 6. So 6 to 14 will give you 2 again, and you will remain 2. You come here and write the 2. 3 times 3 will give you 1. Plus these 2 that you are carrying, again, 3 times 3 9 plus the 2 will give you 11 divided by 6. That would be 1 remainder 5. So you first of all write the 5 and then you write 1. I hope you got what we did. 3 multiplied by 5 will give you 15. You cannot write 15, so you divide by 6 because you are working in base 6. If you divide 15 by 6, 6 will go in 15 2 times. 6 times 2 is 12. No, it will remain 3. This remainder, you put it under the first digit, under the first column. Again, you use 3 to multiply 4. You get 12. You cannot throw away what is left, which is the one you are carrying over. You add that to 12, it becomes 14. 6 in 14, you see as 2. Remainder 2. You take this remainder, you put it here under the second column, and then you carry the 2 over. 3 times 3 will give you 9, which is this 9, plus these 2 you are carrying over, making 11. 11 divided by 6, you have 1. 6 will go in 11 one time, and you will have 5 left. You will write that remainder first, and you carry over beside it. The same thing for 4. 4 times 5 is 20. 20 divided by 6. You will find out that 6 will go in 20 3 times. And you will remain 2. So, you will write the remainder again under 4, not here, under 4. And you carry 3 over. 4 times 4 is 16. You write 16 plus the 3 that you are carrying over, again divided by 6. 6 will go in 19 because 16 plus 3 will now be 19. Again 3 times. What you have left is remainder 1. You come here, you take that remainder, you put it, you carry it over. And then you will say 4 times 3, which is 12. 12 plus the 3 that you are carrying over will give you 15. Again, divided by 6, always, because you are working in base 6. That will give you 2, because 6 will go into 2 times, and the remainder, you will add 4 left. So again, you write the remainder first, and then the carryover number, then you add it. Once you follow this kind of process, you will not have problem. The only issue when you try to cut corners, then what you have gotten for the 2 digits that you are using to multiply 3, 4, 5, you now start adding it together. 3 plus nothing is there, so you write 3. 2 plus 2, 4. You don't have a problem because it's not up to 6. 5 plus 1 is 6. You cannot write 6 here, and the reason is you are working in base 6. So that 6 that you have gotten, you will say 6 divided by 6. You will get 1 remainder 0. So you write 0 here. You carry 1. 1 plus 3, 4. Plus this 1, you will get that 1 that you are carrying. You add it to all this, it becomes 5. And then you bring down the 2. So your final answer is 25043 base 6 if you multiply these two numbers together. 25043.